Introduction to Graphical User Interface. Introduction. We will discuss the following topics in this chapter: AWT architecture, lightweight versus heavyweight, AWT event model, AWT event hierarchy and event handling, using top levels, components and containers, introduction to layouts, focus architecture. AWT architecture. Java AWT. AWT means Abstract Windowing Toolkit. It is an API to develop GUI or window-based application in Java. Java AWT components are platform dependent. That is, components are displayed according to the view of the operating system. AWT is heavyweight, that is, its components use the resources of system. The java.awt package provides classes for AWT API such as text field, label, text area, radio button, checkbox, choice, list, etc. Container. The container is a component in AWT that contains other components like buttons, text field, labels, etc. The classes that extend container class are called container, such as frame, dialog, and panel. Window. The window is the container that has no borders and menu bars. You must use frame, dialog, or another window for creating a window. Panel. The panel is a container that doesn't contain title bar and menu bars. It can have other components like buttons, text field, etc. Frame. The frame is the container that contains title bar and can have menu bars. It can have other components like button, text field, etc. Useful methods of component class. Method and description. Public void add of component C. It inserts a component on this component. Public void set size of integer width, integer height sets the size, width and height of the component. Public void set layout of layout manager M, which defines the layout manager for the component. Public void set visible of boolean status, which changes the visibility of the component. By default it is false. Java AWT example. To create simple AWT example, you need a frame. There are two ways to create a frame in AWT: by extending frame class inheritance. Simple example of AWT by inheritance. By creating the object of frame class, that is association. Lightweight versus heavyweight. Lightweight components. They are not tied directly to GUI components supported by underlying platform. Heavyweight components tied directly to the local platform. AWT components. Some swing components. Understanding the Z order. Top level component in swing bracket J window, J dialog, J applet and J frame is heavyweight, while everything else is not. If a heavyweight component is added to a container that has lightweight components, the heavyweight is always on top. The lightweight component must share the same Z order as the parent container. Lightweight components cannot draw themselves outside the container. They reside in or they are clipped. Mixing swing and AWT. Let's discuss some of the common problems that will occur if light and heavyweight components are mixed. Overlapping heavyweight and lightweight components. The basic strategy is to ensure that lightweight components and heavyweight components in the same container do not overlap. This figure shows a list of layout managers and panes that can and cannot be used to be mix lightweight and heavyweight components. Heavyweight components in front of lightweight menus. Heavyweight components are always drawn in front of lightweight menus. The problem is any menus that are drawn or placed behind the component. Hence, a user may bring up a menu but unable to select a specific menu item. This figure shows 4 heavyweight panels positioned in front of a lightweight edit menu. While you can still select a menu, you can't see it. The repainting mechanism in Java redraws the heavyweight panels over the menus as they are activated. Pop-ups. Pop-up components include elements found in swing menus, pop-up menus, and combo boxes. These components get into trouble because they may be called upon to display themselves outside the confines of their heavyweight top-level container. Spring can use a heavyweight AWT window to display the pop-up instead. Pop-up components in Swing contain a property called lightweight pop-up enable that allows them to switch from lightweight to heavyweight to display themselves. To mix lightweight and heavyweight components, you should always set the lightweight pop-up enable property for any pop-up in the application to false, including menus. This figure shows which type of component Swing uses in various scenarios. Heavyweight components in J-scroll pane. Heavyweight components don't work in J-scroll pane. The component inside the J-scroll pane object fails to clip properly when it is placed inside the pane, and visible artifacts are easy to pick up. Heavyweight components inside internal frames. It is a bad idea. The problem here is that internal frames can overlap by design. The component is still drawn on top of the overlapping internal frame if an overlap occurs and the internal frame with the heavyweight component is on the bottom. AWT event model. Events are handled in terms of event sources and event listeners in Java. An event source is an object that produces an event, and an event listener is an object that wants to be informed when an event occurs. For example, a button is an event source and an animation object might be an event listener. Using an add XXX listener. How do the sources know who is interested in their events? There are two parts of the communication. The setup, who is listening to whom. The event, when sources inform listeners of the occurrence of an event. To handle this, each component has methods that can be used to register objects as listeners for its events. These methods are of the form add XXX listener of XXX listener I, where XXX describes the kinds of events that are of interest. For example, all component objects have a method add mouse motion listener of mouse motion listener I. So if foo is a component and bar wants to know about mouse events in foo, we can say that foo dot add mouse motion listener of bar, provided that bar implements the mouse motion listener interface. Listener interfaces. The mouse motion listener interface has the following methods: public abstract void mouse drag of mouse event E, public abstract void mouse mode of mouse event E. So any object that wants to listen for mouse motion events must implement this interface by providing bodies for these methods. The parameters to the methods in a listener interface are used for passing information to the listener about the event that occur. For example, a mouse event object has getX and getY methods for finding out where the mouse was when the event occurred. Most listener interfaces and event types are contained in the package java.awt.event. Event model example. If we want a text field the user can type into, and we want a button that can be used to reset the text field to a default value, something like shown below. In the below given program, when the user is click the reset button, then the text in the text box will be resetted. AWT event hierarchy and event handling. Event classes. The hierarchy of event classes are shown below. Can create custom non-AWT event classes. Event object contents. java.util.event object. The source holds a reference to the object that fired the event. java.awt.awt event. ID indicates event type. Set to a constant in specific event classes. java.awt.event.action event. Modifies indicates state of control, shift and meta keys. Action command holds the action specific command string, usually the label of a button or menu item. java.awt.event.adjustment event. For scroll bars, value holds value. Adjustment type is unit, block and track. java.awt.event.item event. For choice, list, checkbox and checkbox menu item. State change indicates selected or deselected. java.awt.event.text event. Listeners are notified of every keystroke that changes the value. Listeners are also notified when set text is called. java.awt.awt event. java.awt.event.component event. ID indicates moved, resized, shown or hidden. java.awt.event.container event. ID indicates added or removed. Child holds a reference to the component added or removed. java.awt.event.focus event. ID indicates gain or lost. Temporary indicates temporary or permanent. java.awt.event.window event. It indicates open, closing, closed, iconified, de-iconified, activated and deactivated. java.awt.event.input event. Modifies is a mask that holds state of control, shift and meta keys, state of mouse buttons 1, 2 and 3. When holds, the time event occur. Java.awt.event.key event. It indicates type pressed or released. Key character holds the ASCII code of the key pressed. Key code holds a constant identifying the key pressed. Java.awt.event.mouse event. This indicates click, press, released, move, entered, exited or drag. Click count holds the number of times button was clicked. X, Y hold location of mouse cursor. The class hierarchy and methods are as shown below. Event sources and their listeners. Component. All components extends this component listener, focus listener, key listener and mouse listener and mouse motion listener. Dialog window listener. Frame window listener. Button action listener. Choice item listener. Checkbox item listener. Checkbox menu item listener. List item listener, action listener. Menu item, action listener. Scroll bar, adjustment listener. Text field, action listener and text listener. Text area, text listener. Listener adapter classes. Provide empty default implementation of methods in listener interfaces with more than one method. They include java.awt.event component adapter, java.awt.event focus adapter, java.awt.event key adapter, java.awt.event mouse adapter, java.awt.event mouse motion adapter, java.awt.event window adapter. To use, extend from them. Override methods of interest. Usefulness is limited by single inheritance. Can't do if another class is already being extended. Implementation for methods that are not of interest could look like this. Public void window iconified of window event E. Event handling. Any program that uses GUI, that is graphical user interface, such as Java application written for Windows, is event driven. Event describes the change of state of any object. Example, pressing a button, entering a character in text box. Components of event handling. Event handling has three main components. Events. An event is a change of state of an object. Event source. Event source is an object that generates an event. Listeners. A listener is an object that listens to the event. A listener gets notified when an event occurs. How events are handled. A source generates an event and sends it to one or more listeners registered with the source. Once event is received by the listener, they process the event and then return. Events are supported by a number of Java packages like java.util, java.awt and java.awt.event. Important event class and interface. Event class, description and listener interface. Action event generated when button is pressed, menu item is selected and list item is double clicked. The interface is action listener. Mouse event. It is generated when mouse is dragged, moved, click, press or released, also when enters or exit a component, that is mouse listener interface. Key event. It is generated when input is received from the keyboard, that is key listener interface. Item event. Generated when checkbox or list item is clicked, that is item listener interface. Text event. Generated when value of text area or text field is changed, text listener interface will be used. Mouse wheel event. Generated when mouse wheel is moved, mouse wheel listener interface is used. Window event. Generated when window is activated, deactivated, de-iconified, iconified, open or closed. Window listener interface is used. Component event. Generated when component is hidden, moved, resized or set visible. Component event listener interface is used. Container event. Generated when component is added or removed from container. Container listener is used. Adjustment event. Generated when scroll bar is manipulated. Adjustment listener is used. Focus event. Generated when component gains or loses keyboard focus. Focus listener interface is used here. Example. Using top levels. Swing provides three generally useful top-level container classes: JFrame, JDialog, and JApplet. Instructions to use these classes. Every GUI component must be part of a containment hierarchy to appear on screen. A containment hierarchy is a tree of components that has a top-level container as its root. We will show you one in a bit. Each GUI component can be contained only once. If a component is already in a container and you try to add it to another container, the component will be removed from the first container and then added to the second. Each top-level container has a content pane that, generally speaking, contains the visible components in that top-level container's GUI. You can optionally add a menu bar to a top-level container. The menu bar is by convention positioned within the top-level container but outside the content pane. Some look and feels such as macOS look and feel give you the option of placing the menu bar in another place more appropriate for the look and feel, such as at the top of the screen. Here is a picture of a frame created by an application. The frame contains a green menu bar with no menus, and in the frame's content pane, a large blank yellow label. The containment hierarchy for this example's GUI are shown below. Top-level containers and containment hierarchies. Each program that uses Swing components has at least one top-level container. This top-level container is the root of a containment hierarchy, the hierarchy that contains all of the Swing components that appear inside the top-level container. A standalone application with a Swing-based GUI has at least one containment hierarchy with a JFrame as its root. Example, if an application has one main window and two dialog, the application has three containment hierarchies and thus three top-level containers. One containment hierarchy has a JFrame as its root, and each of the other two has a JDialog object as its root. A Swing-based applet has at least one containment hierarchy, exactly one of which is rooted by a JApplet object. Example, An applet that brings up a dialog has two containment hierarchies. The components in the browser window are in a containment hierarchy routed by a JApplet object. The dialog has a containment hierarchy routed by a JDialog object. Adding components to the content pane. Frame.getContentPane of dot add of yellow label, border layout dot center. As the code indicates, the content pane of a top-level container can be seen by calling the getContentPane of method. The default content pane is a simple intermediate container which derives it from JComponent and that uses a border layout as its layout manager. The getContentPane method returns a container object, not a JComponent object. To make a component the content pane, use the top-level container's setContentPane method. For example, create a panel and add components to it. JPanel content pane equal to new JPanel of new border layout. Content pane dot set border of some border. Content pane dot add of some component, border layout dot center. Content pane dot add of another component, border layout dot page underscore end. Top level container dot set content pane of content pane. Adding a menu bar. All top level containers can hold a menu bar. Create a JMenuBar object, populate with menus and then call setJMenuBar to add a menu bar to a top level container. The top level demo adds a menu bar to its frame with this code. Frame.setJMenuBar of green menu bar. The root pane. Each top level container relies on a reclusive intermediate container called the root pane. The root pane manages the content pane and menu bar along with a couple of other containers. List of the components that a root pane provides to a frame. The layer pane contains the menu bar and the content pane and enables Z ordering of other components. The glass pane is often used to intercept input events occurring over the top level container and can also be used to paint over multiple components. Components and containers. Component is the basic user interface object in Java and is found in all Java applications. Components include list, buttons, panels, and windows. A container is a component that manages other components. Containers display components using a layout manager. Swing components inherit from the Java x.swing.jComponent class. Swing provides the following useful top-level containers, all of which inherit from JComponent. JWindow, a top-level window that doesn't have any trimmings and can be displayed anywhere on a desktop. A heavyweight components usually use JWindow to create pop-up windows and flash screens. Extends AWT's window class. JFrame, a top-level window that can obtain borders and menu bars. A subclass of JWindow and thus a heavyweight component. You place a JFrame on a JWindow. Extend AWT's frame class. JDialog, a lightweight component that used to create dialog windows. You can place dialog windows on a JFrame or JApplet. Extends AWT's dialog class. JApplet, a container that provides the basis for applets which run within the web browsers. A lightweight component that can contain other graphical user interface components. Extends AWT's applet class. Each top-level container depends on another intermediate container called the root, which provides a number of components to each. Each top-level container consists of the following panes. Root pane. The root pane is an intermediate container that intermediates among the layered pane, content pane, and glass pane. It can also manage an optional menu bar. You use a root pane to paint over multiple components or to catch input events. Layered pane. It contains a content pane and the optional menu bar. It can also contain other components of it arranges so that they overlap each other. The layered pane provides 6 functional layers where placing the components you add it can be done. Content pane. The content pane holds all the visible components of the root pane except the menu bar. It spreads its umbrella on all the visible section of the JFrame or JWindow and added components are there in the display area. Java automatically generates a content pane when you create a JFrame or JWindow. Instead, you can create your own content pane of opaque. Glass pane. By default, the glass pane is invisible, but you can enable it visible. When it becomes visible, it contains the components of the content pane, blocks all input events from reading these components, and can paint over an existing area containing one or more components. JComponent services. The JComponent is the root class for all Swing components such as JPanel, JLabel, and JButton. This class inherits from the container class and enables for adding containers and components to an application. It credits the following functionality features to its subclasses: customizing component appearance, checking component states, adding event handling, painting components, modifying the containment hierarchy, arranging the layout of components, retrieving component size and position information, text component printing. Using components and containers. All Swing applications have a containment hierarchy with the top level container as its root to which components can be added. For example, you can create a dialog within a JFrame container by adding a JDialog container to it via content pane. Use the add method to add components to all containers except JFrame and JWindow. Use the setVisible method to make the component visible. After adding the components to a container, you can set their size. Use the setSize method. Specify the focus. Use the setFocusable method. Introduction to layouts. Layout can be defined as the arrangement of components within the container. Layout Manager. The Layout Manager automatically stabilizes all the components within the container. Though it is possible to layout the controls by hand, it becomes very difficult due to the following 2 reasons. It is very tedious to handle a large number of controls within a single container. Often the width and height information of a component is not given while arranging them. When either the size of the applet or the application window changes, it reflects a change in the size, shape, and arrangement of the components. That is, it adapts to the dimensions of applet viewer or the application window. It is associated with every container object. Each layout manager is an object of the class that implements the layout manager interface. The layout manager interface declares those methods to be implemented by the class whose object will act as a layout manager. The layout manager too is a sub-interface of the layout manager, which is for those classes that know how to layout containers based on layout constraint object. AWT Layout Manager classes. Following mention is the list of commonly used controls when designing GUI using AWT. Border Layout. The border layout arranges the components to fit in the 5 regions like East, West, North, South, and Center. Card Layout. The card layout object treats each component in the container as a card. Only one card is made to be visible at a time. Flow layout. The flow layout is the default layout. It layouts the components in a directional flow. Grid layout. The grid layout manages the components in form of a rectangular grid. Grid back layout. This is the most flexible layout manager class. The object of grid back layout aligns the component vertically, horizontally, or along their baseline without requiring the components of same size. Focus architecture. When the user presses keys on the keyboard, focus specifies the components that receives keyboard events. The keyboard focus manager manages state and initiates changes. It is a critical element of the focus subsystem. It tracks the focus owner. The component receives typing from the keyboard. The focus window is the window that contains the focus owner. A focus cycle or focus traversal cycle is a set of components that share a common ancestor in the containment hierarchy. The focus cycle root is the container that is the root for a particular focus traversal cycle. The following swing objects can be focus cycle roots: JApplet, JDesktop pane, JDialog, JEditor pane, JFrame, JInternal frame, and JWindow. A focus traversal policy determines the order of a group of components is navigated. Swing provides the layout focus traversal policy class. It decides the order of navigation based on layout manager dependent factors such as size, location, and orientation of components. Within a focus cycle, components can be navigated in a forward or backward direction. Components are navigated in most look and feel models by using the Tab and Shift tab keys. These default focus traversal keys intended to be modified in program voice. Example: adding enter can give a forward focus traversal key with the following 4 lines of code. Set forward keys equal to get focus traversal keys of keyboard focus manager dot forward underscore traversal underscore keys. Set new forward keys equal to new hash set of forward keys. New forward keys dot add of keystroke dot get keystroke of key event dot vk underscore enter comma 0. Set focus traversal keys of keyboard focus manager dot forward underscore traversal underscore keys comma new forward keys. Tab shift the focus in the forward direction. Shift tab moves the focus in the backward direction. Validating input. GUI design can be a common requirement. It is a component. It controls the user's input. Formatted text field components can be helpful in using an input to a variety of localized formats. Custom formatter can also be used. Instead of custom formatter, input verifier can be an alternative. It permits a programmer to deny specific values like a properly formatted but invalid zip code or values outside of a desired range. In order to use an input verifier, you create a subclass of input verifier, create an instance of your subclass, and set the instance as the input verifier for one or more components. Private myVerifier equal to new myVerifier of amount field dot set input verifier of verifier. Whenever the component is about to leave the focus, a component's input verifier is consulted. If the component's value is not acceptable, the input verifier can take appropriate action, such as refusing to yield the focus on the component or replacing the user's input with the last valid value and then allowing the focus to transfer to the next component. Input verifier is not called when the focus is transferred to another top-level component. Making a custom component focusable. For gaining the focus, a component must satisfy 3 requirements. It must be visible, enable, and focusable. Example: public picture of image open bracket this dot image equal to image. Set focusable of true. Add mouse listener of this add focus listener of this bracket closed. The call to the set focusable of true method enables the component focusable. Picture has a focus listener to visually show changes in the focus by drawing a red border only when the component has the focus. To the component has a mouse picture to seek the focus while clicking on the picture. The listener's mouse click method requests for the focus to be transferred to the picture. Public void mouse click of mouse event E open bracket. Since the user clicked on us, let us get focus. Request focus in window of close bracket. Customizing focus traversal. The focus subsystem decides a default order that is applied while the focus traversal keys are used to navigate. The setFocus cycle root method used to set a focus traversal policy on any container. Use the isFocus traversal policy provider method to determine whether a container is a focus traversal policy provider or not. Use the setFocus traversal policy provider method to set a container to provide focus traversal policy. Tracking focus changes to multiple components. Registering a property change listener on the keyboard focus manager can be done unless a focus listener is appropriate. The property change listener is notified of every change involving the focus, including changes to the focus owner, the focused window, and the default focus traversal policy. The Focus API. The Focus API falls into 4 categories. Useful methods for components. Creating and using a custom focus traversal policy. Input verification API. Keyboard focus manager properties. Useful methods for components. Method and its purposes. Is focus owner. Returns true if the component is the focus owner. Set request focus enable of boolean. Is request focus enable bracket in J component. Sets or checks on whether this component will get the focus. Setting the set request focus enable to false typically prevents mouse clicks from giving the component the focus. The keyboard navigation continues to give the component the focus. It is applicable only for the components receiving mouse events. Set focusable of boolean is focusable method. If the component is insisting the focus, it must get the focusable state of the component. When a component has been eliminated from the focus cycle with set focusable of false, it can no longer be navigated with the keyboard. Request focus in window. Request that this component ought to get the focus. The component's window must have the current focus window. Set focus traversal keys of integer, set. Get focus traversal keys of integer. Or focus traversal keys set of integer. Bracket in java.awt.container. It sets or gets the focus traversal keys for a particular direction or determines whether any focus traversal keys have been explicitly set on this container or not. Creating and using a custom focus traversal policy. Class or method and its purpose. Layout focus traversal policy. The class that by default determines the focus traversal policy for swing components. Get component after of container, component. The given component is passed as input and returns the components that immediately have the focus. Get component before of container, component. The given component is passed as input and returns the component that should have the focus before this component. The method is used for backward tabbing. Get default component of container in javax.swing.sortingFocus traversal policy. Returns the component that should have default focus. Get first component of container. Returns the first component in the traversal cycle. Get initial component of container. Returns the component that should receive the focus when a window is made visible for the first time. Get last component of a container. Returns the last component in the traversal cycle. Set focus traversal policy or focus traversal policy. Get focus traversal policy or focus traversal policy. Sets or gets the focus traversal policy or determines if a policy has been set. Setting a focus traversal policy on a container must be noted carefully. It is not the focus cycle roots which have no apparent effect. A policy has not been explicitly set. If no policy has been set, a policy is inherited from the parent focus cycle root. It is termed as value of null. Is focus cycle root of. Set focus cycle root of Boolean in java.awt.container. Checks or sets whether a container is the root of a focus traversal cycle. Is focus traversal policy provider. Set focus traversal policy provider of Boolean in java.awt.container. Checks or sets whether a container will be used to provide focus traversal policy. The following table shows about Input Verification API. Keyboard Focus Manager properties. This table defines bound properties for Keyboard Focus Manager. A listener can be registered for these properties by calling add property change listener property and its purpose. Focus owner. The component which currently receives key events. Permanent focus owner. The most recently received component has permanent focus underscore gain event. It is typically similar to focus owner unless a temporary focus change is currently in effect. Focused window. The window that is or that contains the focus owner. Active window. The component certainly has to be either a frame or a dialog. Default focus traversal policy. The default focus traversal policy, the set focus traversal policy method can be set in the container class. Forward default focus traversal keys. It is a set of default focus keys for a forward traversal. These keys default to Control tab for multi-line text components. Backward default focus traversal keys. These are the set of default focus keys for a backward traversal. For multi-line text components, these keys default to Control Shift tab. Upcycle default focus traversal keys. These are the set of default focus keys for an upcycle. These keys are null by default for swing components. Downcycle default focus traversal keys. These are the set of default focus keys for a down cycle. These keys are null by default for swing components. Current focus cycle root. The container that is the current focus